Just a review of what we did in class, and then I will do some extra stuff that we didn't get to in class. Okay, so there's a difference between weather and climate. Weather conditions are the weather for today, the actual climate at any given time. Today's weather includes being nice and cool in the morning and then 85 in the afternoon. That is the weather, intensity of solar radiation, the temperature, the precipitation, the wind direction, things of that nature. That is the weather, brought to you by the weather guy on your news. Again, this is determined, climate is determined more by solar radiation. So this is going to be where you are in the equator, right? The equator is going to get the maximum amount of solar radiation. As it increases in latitude, you're going to get less solar radiation. It's not going to come directly at you. So it basically influences all other climate variabilities. The most important thing is the amount of solar radiation that you get. This basically determines everything else. It determines what can grow in a given area. Modified by large-scale factors such as mountains, valleys, oceans, lakes, smaller climates, buildings, rivers, small ponds, small valleys. There are microclimates here at Pompon. In between buildings, there'll be different wind or shaded areas. This determines the vegetation. Is it too cold there? Is it too windy there? It includes what kind of subspecies can be adapted to that local climate. Solar radiation, again, is a continuous but uneven spectrum from a short wavelength to a long wavelength. Unevenness comes from the absorption of light by the atmosphere, and this is going to be as you get further away from the equator. Solar radiation are measured in nanometers. The solar spectrum ranges between 300 nanometers to 2,000 nanometers, but the photosynthetic radiation is really only between 400 and 700. So that's all we care about. And when you are looking at photosynthetic radiation, you're also looking at, in a greenhouse, when you're trying to provide artificial light, you're really thinking about this wavelength of 200 to 700. If it doesn't produce that wavelength of light, it's really useless light for plants. Here again is the equator and the amount of solar radiation that you're getting. Solar energy reaching Earth's surfaces. It's going to maximize here at the equator. Reaching the Earth's surfaces, the solar radiation passes through more air and is spread over a wider area at higher altitudes. So here are the higher altitudes. You're going to get less solar radiation. Again, this varies with season and cloud cover, and the Earth tilts. This should not be brand new information. The Earth tilts. So yes, you're going to get the most at the equator, but you also are going to get a different distribution depending on the seasons. Seasonal variation is obviously going to be the greatest at the poles, where they get all sun or all darkness. And it's going to be the least notable at the equator and most notable at the solstices on any given side. So the tilt of the Earth's axis influences day length. On the equinox, day length is 12 hours everywhere. This is what you need to grow poinsettias. The summer solstice, this is the longest day of summer. The winter solstice is the shortest. I actually always like the solstices days because it tells me that the season is changing. Winter solstice is like, well, it's going to start getting lighter. There's hope at the end of the tunnel. Even though light intensity is the lowest at the poles, during the short summer, day length is long enough for plants to grow. So there are tundra plants. It is possible to photosynthesize in the tundra. Basically, it's not practical outdoors to really supplement solar radiation. You can do it, but not for long periods of time. It can be done on short periods of time to increase the effects of frost and things like that if something's coming, but it's typically, there are better ways to do it. You usually supplement solar radiation inside in greenhouses or production facilities, like one of those hoop buildings that come around. That is where you would try to supplement your solar radiation. Okay, there are different types of solar radiation used in greenhouses. We are getting much more efficient with these, and there are way better options than there used to be. So high intensity discharge lamps and LEDs are typically what you're choosing from. Supplement solar radiation in greenhouses, and they replace solar radiation in facilities that have non-transparent surfaces. So if you are going to grow pot in your basement, you're going to want something that has a high intensity because you're not just supplementing it, you are providing all of the light for it. So if you're going to try and grow something in a cave or a shed with no windows, you're going to need way more intense solar radiation. And you also have to look at, when you're making this decision in a greenhouse, you have to look at how much heat is being emitted and what are you trying to get rid of. If you want to use your lights to both heat and provide solar radiation, you're going to want different lights than if you go with a low emitting LED that does not produce any heat, you're going to have to supplement with heat. If you have been heating, part of your heating has been coming from lights, when you switch to a more energy efficient lighting system, you're also going to have to supplement your heating system. But it's also going to save you money in the summer if you're trying to keep your greenhouse cool. So those are things to think of when you're growing plants with supplemental light. What you have to think of, and we talked about this in class, photoperiod. You have short day, long day, and day neutral plants. This is going to determine the growth and development of these plants, and it's going to tell them when to turn on their reproductive cycle. So short day plants flower only when the day length starts getting shorter. Long day plants flower when the day length is longer. So long day plants, you're going to see that as the spring days get longer, that's when you're going to see a lot of flowering. So a lot of your flowering kind of plants in the spring, those are going to be long day plants. They're not actually flowering because of temperature, they're flowering because of sunlight. Photoperiodism. This is the very cool parts of plants where they grow towards the light. If I had my plants here in my window, they don't have very long stems, but if they did, they would grow towards the light. This is basically a way to manipulate the light period to control flowering. Low intensity effect would happen when you get a spindly plants growing trying to find light. You don't want that. You want to make sure in your greenhouse, in your office, everybody's getting enough light so they don't have to grow towards it. It creates really weak, thin, spindly looking stems that are not very pretty for ornamental sake, and they don't stand up to things for crop sake if they're out in the middle of a field. Again, photoperiod crops such as soybeans have cultivars that are suitable for different latitudes so they don't get all spindly trying to look for different light. Farmers, growers, you need to know what your light, if there's a photoperiod on your seed, you need to know what you are looking for. Photomorphogenesis, plant shape determined by light quality. So again, this is the photochrome in the protein. It's responsible. It'll change to a red spectrum, and that is when it's too much in the shade. So when it's in the shade or the days start getting shorter, that end of day shift to the far red light will happen under canopies. So under here, they're going to get a different kind of light because this plant is shading them. So they're not going to get the appropriate kind of light and they're going to get all spindly to try and go around it. That is photomorphogenesis. Far red high, red low, under, and within leaf canopies. So this is just basically you're going to get tall, spindly plants in high, far red light to avoid shade. The survival mechanism to get tall, to reach sunlight, is for them to grow a spindly stem to come out from that shade. If this is the shade, it's going to grow over here. And if you start seeing that happen, you're really going to need to change your plant spacing so everybody's getting more light. Increase your plant spacing, move your plants apart, maybe cut some leaves off different places. We're going to talk about moisture in the next